Um, Before I move on from floats, I'm going to talk about you can kind of convert between integers and floats for this situation. So I have integer a equals 10 and integer b equals 3 or something. And I want to know what 10 divided by 3 is. So if I do float, okay, I'm expecting a, let's do fraction equals a divided by b. I'm expecting this to give me what do we want? 3.33, I think. 33333, 3 and 1/3, is what we're expecting from this fraction. So if we go ahead and do this, um, what we're going to expect is 3.333, but we're not going to get that. We're just going to get 3. And the reason for that is because these are integer types, when you use this, the binary division operator, binary, by the way, for operators just means that you have two kind of um, numbers in your little expression here. Unlike a unary operator, which is like 1, that would be like a plus plus. It only has one kind of parameter, while a divided by b has two. So anyway, this fraction is coming out as a whole number because both of these are integers, and so it's going to return an integer to fraction. If you want 3.333 or a floating number, you need to either declare one of these as a float. So if we have float a equals 10, a over b, we should get, yeah, there we go, 3.33333. But if you're being fed integer values and you need to find the fraction, you can do something called type casting, which is really just a clever way of saying convert between integers and floating points. Or you can do it with other data types too. The way this works is there's kind of a complicated way and a more easy way. Obviously the easy way is kind of easier, but um, it's kind of depreciated or deprecated, however you say that. I'll show you the easy way because um, it's I don't think it's that bad really, especially for small scale projects. We're not getting into anything really big yet, so it's probably okay. The way that you do this is you would type float and then use float as if it were a function name to typecast a into a float. So as you see, if we go ahead and compile and run this, you're going to see we're getting 3.333, and that's because we're converting this a, this integer, to a float for the purposes of this mathematical expression. Um, and that's gonna give us a floating point number back into fraction. You can also see this written as in parentheses like this, float a over b, and that should have the same result, 3.333. So that can be useful when you need to divide by or need to do some quotients with integers and you want precise decimals. Obviously, this does have a limit to its precision because it doesn't go on forever. Um, so that's something to keep in mind. There is a limit to how how precise these decimal numbers can be, and for that reason, there is an even more precise type of decimal, and that would be the double type. It doesn't have anything to do with multiplying numbers by 2, um, but it is a mathematical kind of type, and can still do mathematical stuff like this, division and everything that integers and floats can do, doubles can do as well. But doubles are actually bigger data types. They take up 8 bytes instead of floating points, which take up 4. Integers also take up 4. So you kind of want to minimize the amount of memory usage that your program needs. So only if you really need this kind of this level of precision do you need to use doubles. Um, this isn't, I mean, it's the same number of decimal places, but doubles still do take up 8 bytes instead of 4. So those bytes are kind of committed to holding this data in that doubles can probably go higher than floating points can and do various other operations with a greater level of kind of, what's the word? I don't remember, but it can do stuff more versatile operations than floats can. But if you don't need doubles, don't use them because they're just going to increase the data usage of your program, which can be kind of frustrating because if you've ever had two programs running at the same time and they're kind of, you end up with a lot of lag and your computer becomes sluggish. That can be caused by many things, one of which is kind of they're competing for memory that they want to allocate, and they're both trying to allocate so much memory that your computer is kind of having to wait for that memory to be freed before it can allocate it again. So you kind of want to minimize the amount of memory usage that you have to use. So that's something to keep in mind. So one more data type that you can use, that I'll talk about briefly, are characters. So these are exactly what you might expect. They can equal uppercase, lowercase. They can also equal numbers like 7 or whatever, or B, or note the single quotation marks. That's because a single character is only a single character, so you use single quotes to kind of represent that. You can't go like, if you wanted to store your name or something, my name's Duncan, you can't do it like this, with having several characters kind of strung together and trying to store them in one character. That's not fit for the character data type. There is a way to do that. Actually, there are a few ways to do that, but that's kind of beyond where we're at right now, so I'm going to talk about that later. For now, uh, you you characters are kind of less interesting than maths stuff that you can do. Um, but there's something to keep in mind. We are going to get more into them later and more that you can do with them. Um, oh, I don't think you can do 19 because that's 2 characters. Note it is treated as characters, so this is not the number 19. It's the number, it would be the characters 1, 9, and that's probably going to give us an error if we try to compile. Yeah. Oh. Hey. Oh, it didn't give us an error, just a little warning. Multi-character and constant. I don't know what this is gonna... Yeah, so when you try to run your program, you're gonna get some unpredictable results. Like, it's not gonna have the 1 because it can only have 1 character. So when you try to see out or output this character, it's only gonna give you 1. So they're not treated like numbers, they're treated kind of differently, just because of their data type. So it's something to keep in mind. Like I said, we're gonna talk a little bit more about them. And we're going to get into some other data types, and like I said before, you are going to be able to create your own data types, which can get really cool, and it's kind of the key feature that C++ has that C kind of lacked is the way that you can make your own data types. So we're going to be talking about that, not too far off, so get excited. I think that's it for this video about data types. Uh, um, we're going to move on pretty soon. These are really fun videos to make, guys, and I hope that you're enjoying watching them. Like I usually say, if you like this video, go ahead and give it 4 or 5 stars. If you're not feeling it, 1 or 2 is fine. I'll appreciate feedback, positive or negative. If if you're having trouble, or you just want some help, go ahead and leave a comment, or message me on YouTube. I'll try to help. If you're liking the videos, hit the subscribe button. That'll inform you whenever I upload another one, so you'll get to know instantly that there's a new one available. So if you like to keep watching them, go ahead and subscribe. I'll see you guys in the next video. Thanks.